Hello everyone and welcome to another video of Fake Learns. In the last video of PepCoding Recursion that we had made, we had revived the sprint array max question. So the question was something like we were given an array and from that array we had to find the maximum element which is present. So let's continue the revision of the next question. So the next question that we had done was this first index official. Okay, so we were given an array again here, and we were also given an input element, and we had to find the index where the element occurred for the first time. Okay, so let's try to imagine this. Suppose we have an array with 15, 40, 14, 4 and 4 again, let's say, and we have to find the first index of occurrence of data element is 4, and the element that we are given to find is 4. Yeah. So we should return this index that we have. So let me write the indexes here: 0, 1, 4. Yeah. So we can approach this problem using the faith expectation solution that we have, and in that also we can start from the 0th index and from the last index and then go to the 0th index. But here's what specifically we found, that we have to find the first occurrence, right? So the first occurrence will start from the 0th index, so it's better that we start the iteration from 0. So let's set the expectations that if we have a find first index kind of method which accepts array comma the index which is we'll start the iteration from 0, so let's consider 0 is the first occurrence, and then what else, the element, right? And the element is 4. So if we are given this, then the expected output is that it should print 3, right? That the third index is the first occurrence of 4. And the faith, let's establish the faith that if we are given this with an index as 1, then it will find all the occurrences of this element in 3. Okay, so it will try to find all the occurrences of 4 which are present from the 0th element to 1 less than the last element. So that is the expectation and faith that we have established. So what will we do? So we will get the index and we will compare it with the next index, with the next element that is present. So we'll get the index. Okay, so let's say we get 3, then we do ARR of I and we compare it with the element, not the next element. We compare it with the element that we have, and if that matches we directly return. So let's try to code in that. So where's the question? Print first index, right? So we'll see some different variations of this as well, but let's first try to have the basic approach, right? We have the index, the element. Let's try to code that in once more. So if we are starting from 0, right? So index is equal to ARR dot length will be the condition. Then we return, and what do we return? We return -1, right? And if we find the element, so let's say if ARR of index is equals to element, then what do? We return directly from here, return index. Else what do? We call this method recursively by passing -1 first, ARR, then element, and then index +1, not -1. So let's see how does it fare. Okay, so why is it complaining? I have to return this also, right? So we can also store this in a variable and then return that variable, but yeah. So let's have a dry run in our minds first. So we'll get an array, and yeah, so we'll start the iteration from 0, and we'll first check if it is equal to element, and if it is then we return, otherwise we do index plus plus and we keep on incrementing. Yeah, so I think this should work. Let's try to run it once. So 1, and then we want to find, so yeah, 0 1 2. So second is the index where 4 occurs for the first time. So what if we have another variation where we give the index as we have given the index as 0 here, right? So what if we have another variation where we give the index as array.length? So if we give this, then what does happen? Let's try to code in for that part, like a different variation of this. So the base case will be when we get 0, right? But before that we have to think. So let's set the faith expectation. So we start the iteration from the last element and we check if the element is equal to the array's element, right, is equal to the element that is specified. If it is, then what do? We have to store that, right? Or let's think about it. So we have to call this method recursively then, and once we call this method recursively, then we'll have to do first kill. So let me code it first. Okay, so for find first index of arr comma length comma index -1 this time, right? And then we'll store what if we store int previous index? If we store the element, then we'll go from the last element to the 0th element, and we'll then go from the 0th element to the first one. So this will be not an optimized solution, but let's try to code in once. So for the 0th element we have it already did, right? So if or what we can do is that we can start the iteration from 0th element, and we can have index arr.length minus index, and we can compare the elements and then return. But let's try to do in this where we find it using back tracing. So we will find this element when we are back tracing. So if arr of I, right, index -1 is equals to, if arr of index -1 is equal to, what will be it equal to? If arr of index element, right, then we return index -1. Else what do we return? We return previous index, and then we'll have to have some kind of base case, right? The base case will be when index is equals to 0, then we return -1, because if index is equals to 0, then we return -1. Okay, yeah, this should seem fine, because if index is 0, then it will drop here, and then it will do 1 -1 0. It will again check for the 0th element. Yeah, so this will work. So let's see, we have 6 elements, 44 4, and we want to find 4. So we should get the output as 0 1 1, right? But yeah, oh, 0 1 2 3 4 5, we have we have got the last index as the output, because let me try to recalibrate it. So we come here, we have the index as arr.length, then we do find first index arr element and index minus 1. So first we have 5, right? 5 as the 6 as the output. Then 6 as the element, and then okay, let me have it here once. Then we decrease it, we keep on decreasing, and then we reach 0. Once we reach 0, we should return index minus 1. So it returns index minus 1, so this becomes index minus 1. And then I'll need to have the condition where if index is not equals to minus 1, then we return index if previous index, not index, right? So we are kind of brute forcing our way through here, right? So if we find the element first, then we are skipping all the backtracing iterations that we have. So we go from the last element to the first, the 0th element, and while coming back, we will have to iterate the whole array, right? But if we find the index, so when we find the index, the previous index should not be minus 1. So after that, we just keep on returning previous index. So that is kind of brute forcing it, right? So let's say we have 40 14 4 again 4, yeah. So this will give us the correct output that we have. Yep. So let's try to solve the next, or not solve but revise the next question, right? So the last index, right? So here also we were given an array and we were given an index. We were told to find the last occurrence, the index. The output expected was the index where the element has occurred for the last time. So we had solved that question here, but let's try to revise it. So let's say we have an array and the element is 4, and we give it the input 0. So it should give us the output 4, because 4 has occurred at the 4th index. So this will be find last index. And let's suppose that if we are given 1, then we will, so what do we do if we are given 1? So let's consider that we will find all the occurrences present from 0th element to 3rd element. Okay, so that will give us the output 3. Of 3 is the index present. So let's try to code in here once. So let me have this copied, and then we will comment this. So we'll give the element as 0, then let's try to have the logic here once. If, let's not start with if, right? We have to find last element and index minus 1. We have to store it in a variable, say int previous index. Then what we do is if arr of index minus 1, right? So we'll have to do index minus 1 here uh, because of the edge case that we faced, right? If ARR of index minus 1 is equals to element, then we return index minus 1, else what do we return? We return previous index, right? Yeah, and we'll have some base case. If index is equals to 0, then we return minus 1. Yeah, so let's try to run this once. So let's run it here. Okay, so I'll have some comments here. So let's try to run it here. So for the first time, let's say if we have an ARR which is 40, 4, 12, yeah, so let's say we have this and we give ARR, 4, index as 5, then this will call, this will come here, this will make another recursive call with 4, this will make another recursive call 3, 2, 1, then 0. So for 0, like if we had drawn a stack, then we are typically moving up the stack here, and when we encounter this 0, we return minus 1. So previous index will return minus 1 for this. Once we get previous index as minus 1, the index value here is 1, so 1 minus 1 is 0. So we'll compare the 0th element, right? If we compare the 0th element with the element that we want to find, and then we check if those elements are equal or not. If yes, then we return that particular index. Okay, then the stack will fall here, then fall here, then, so even if we had the first occurrence of 4 here, we are returning the index of 4. So the index of 4 is 0, 1, 2. So this index that we have here, it will override this 2, right? And that is why we'll get the last index. So let's try to run this once. Oops, we got minus 1. Okay, so we have to pass ARR.length, right? Not this. Yeah, let's run it once more. Yeah, so 0, 1, 2, 3, 4. Yeah, so let's try another variation of this where we try to find the element if the index is 0. So if the index is 0, then we'll have to return the last occurrence, right? So if we start the iteration from 0, like we had done here, then what will happen? And let's try to think. So we'll have to check if, so there's no direct way, right? One direct way that I can think is we start iterating from the last element. Okay, so we can have something like ARR dot length, minus 1 minus 0 minus index, right? So index is 0 first, and then it will keep on increasing. Yeah, so if this is equals to element, then we return whatever we found here. Else we just recursively call this method. Index plus 1, and we have here. So if index is equals to, so we'll stop when index is equals to arrow dot length, right? Then we just return minus 1. We need a return statement here also. Yeah. So if we start the iteration from 0, we'll do arr.length minus 1, which is the last element. If we find that element, then we directly return from there. Else we continuously or we recursively call this method by increasing the index. Let's say we have 5, again 40, 12, 4, 2, 4. Yeah, so this is the output that we had got. So the next question that we had solved was which was the next one? The last one in this recursion in array series was all indexes in an array. So okay, so this is the solution. Let's see the problem one. So we were again given an array and we had to find all the indexes of the element that were present in that array, and we had to store those indexes in an array and we had to return that array. So let's say we have this, and then the expected output element was 4, then the expected output was that this 4 element is present at 3, 4, or the order didn't matter, right? So let's try to do it once. So we can start the iteration from, but the main challenge here was that like we had used an array list here, right? Where do we have an array list? Okay, let me find that question. Yeah, so we had used an array list here, so we don't have to use an array list. So what if we want to use an array? If we want to use an array, how do we find the length of the array that we want? So for that we can have a variable, so called times found. So this variable will store the count of the times that the element has occurred. And how will we get that count? So we'll think about that. So first we'll call, and we have to return an int array, let's say. Okay, so let's say first the occurrence of the element is 0, so we'll start from 0. So what we will do is that when we are going up the stack, then we will have this times found. Okay, and when we are coming down the stack, then we will try to fill in that array that we have here. Okay, so what we can do is that we can have times found if arr of index is equals to element, then we increase times found plus plus else we do nothing, right? Yeah, so this is the first. So while iterating up the stack, we do this, and then we do arr comma element comma index So where are we starting the iteration from? So we are starting using the length. So we have to do index minus 1. So we will come down the stack first. We will store all the elements which are present from the last element to the and then we'll try to so we'll count all the elements present from the last index to the 0th index, and then we call this function recursively. This function will return as an array, right? So let's say int result array. Let's say int array, right? So if what if, so if we have index minus 1 equals to the element that is present in that array in that we want, then we just add to this array. And what do we add to? So we add to the times found. So if we look here, we'll start from the last iteration. So we'll increase the count, so the times found will be 2 till it reaches the 0th element, right? And then we again start the iteration from index 0 to 1 2 3 4. Okay, we'll insert into the last index first. So we'll insert into the times found, and then we'll also have to do minus minus first, right? Because the indexes start from 0 as equals to the element that is present, and then we just return, right? Return that result array. Else what do? We just return the result array as it is. Okay, and the base case now. So we start the iteration from the last index. We go to the 0th index by incrementing the count, and then we'll have some conditions here. So if index is equal to 0, then we have to stop stop the iteration, like we have had the base case, right? If we stop the iteration, we'll have to create a new array, right? So we'll have to also check if times found is equals to 0, then we just return a new int array, right, with 0 elements present. Else we have to create an array with the times found as the length. Okay, so let's try to dry run it once. So just to be sure, and thinking we'll have here index minus 1, right? So because we are giving the length, so we'll start the iteration from index minus 1, which is length minus 1. If that is equals to the element, then we increment the count. Yeah, and we don't have to put the element, right? We have to just put this index that we have. So we start iteration from the last. We check if the element in array is equal to the element that we want, and we increment the times found. So times found will be 2. Then we hit the 0. Then we fall to 1. So index error of 1 minus 1, which is 0. If that is equals to the element, then to the last index of this result array that we have, we insert that index. Yeah, so this will run most probably. Let's try to run it for 444444. Okay, we cannot erase now. Then one, let's say an element I want. Okay, so we'll have to print the array as well, right? So we'll have 5 elements for 4, 40, 14, 4, 4, let's say, and we want 4. Yeah, so we have the last element first, the third element, and the 0th element. Yeah, so this is how we found all the indexes in the array. So let's do another variation of this. So what if we are given 0 as the input? Let's try to think. So if we are given this index as 0, then we'll have to iterate from 0 to the last to arr.length. And once we hit arr.length, so while iterating from 0 to arr.length, we have to increment the times count variable. So if arr of index is equals to element, then we have to increment times found. Then we recursively call this find all indexes, and we increment, then we store it in some kind of result array. Okay, so what after this? So after this, what we can do is we can check if, so we'll be iterating from last element, right, from the last element to the first. So if arr of index is equals to element, then we just return index. We don't return the index, we have to store it in this, right? So we store it in result array of times found is equals to index. We have to do minus minus times found, return result array. Else what we do, we return result array. Yeah, we'll need some base condition also, right? So the base condition will be if index is equals to array.length, then we have to return a new array, right? And we have to, before that we need to check if times found is 0 or not. If times found is equals to 0, then we return an empty int array. Else what do we do? Else we return an array with the times found size, right? Yeah, so I think this might just work. Let's see. So once we hit arr.length, we come back to arr.length minus 1, and then we store the indexes. So the last element will be So do we have to do for I forgot, sorry. So we'll start from 0, right? We'll reach AR dot length. So I'm trying to think what array result array will be. So let's say if we have this same 440 12 4 4 and 12 4 440 12 4 4. So we'll start the iteration from 0. We'll have the times count as 3, right, and then we'll hit this base condition. We'll create a new array of f size 3, and then what do? We come here, then we check if index of er dot length minus 1, if this is equals to the element that we want to search for, so that will give us the element that we want. So we'll get the output as reverse this time, like 0 3 4. That's what I'm thinking, but let's check. Four 40. So what did we have? I'm not sure. 0 3 and 4 we had, right? 4 4. Okay, but let's see. Oh, we get an empty array. Why? So let me check here once. Times found is 0 and the index is not the length, index is 0. Yeah, so we have got the array in reverse direction, right? So yeah, this is how we have revived this recursion module that we had already done, and we discussed different variations of the problems. So this was a good refresher, and it definitely made our basics strong, and it just like it kind of opened our minds how we can solve one problem in different variations, right? So that's all for this video. See you guys in the next one. Thank you.